Welcome to today's lesson. So we are still dealing with calculus, and in the previous lesson we dealt with differentiation, which most of you at least grasped the concept. So I believe in the next concept also, because it's much simpler, you are also going to grasp the concept. So today we are continuing. We are looking at how to find the gradient of a curve at any point. So now, before we can look at the sample question here, I have an example of a curve, because some of you might be wondering. So a curve, it will look something like this. So now what we are saying is, you can find the gradient here, you can find the gradient there, you can find there, at any point here, you can find the gradient. Now, how do you find the gradient? Remember, these things here have been properly laid down, because for you to know how to do this, you have to know this. So now, differentiation, dy by dx, is known as the gradient function. So we are saying dy by dx is known as the gradient function. So it's known as the gradient function. So meaning this dy by dx can be used to find the what? The gradient. So dy by dx, in other words, we are saying dy by dx is equals to gradient m, which can also be y2 minus y1 over x2 minus x1. So that is just the gradient function. So for example, if we have a question here which says deduce the gradient of the curve y is equals to x squared at 2, 4. So this is a point. Now this is x, y. Our main interest is the x. So 2, 4. 2, 4, maybe for instance it can be here. So we want to find the gradient here. Okay, so if we want to find the gradient here, now if the question just came without the curve, because this curve is just imaginary. So what we are going to do, the first thing here is, we are going to say, we first of all have to find dy by dx. So y is equals to x squared, dy by dx will simply be equal to, you bring down the 2 here, multiply it with x, so it will just remain 2x, because 2 minus 1, it will still be 1. So this is our gradient function. Okay, so if this is our gradient function, then we know for truth that dy by dx is equals to the gradient, which is equals to, in this case, 2x. And we know that 2x here, they've given us a coordinate because they're saying at 2, 4. So we look for x. So this x here is what? Is 2. So it will just be 2 multiplied by 2. And our gradient in this case is 4. So determining the gradient of a curve at any point is as simple as that. Step number 1, you have to make the gradient function, which is dy by dx. Then step number 2, you have to substitute the value of x into the gradient function, and your gradient is found. So it is as simple as that. And for our practice, our exercise there, let us try this question. For the curve y is equals to x3, find the gradient function. Then b, find the gradient at the point 2, 8, which is exactly what has been done in the example. I believe this one will be a straight and forward thing. So let me see you submit the work in the shortest possible period of time. 10 minutes or so, you should be done. So thank you. I'll be waiting, and we'll meet in the next lesson.